Hello everyone, I hope you all are doing well. Welcome back to AWS AI Engineer Essential Series. My name is Dheeraj Choudhary, and have you ever wondered how companies like Netflix, Uber, and Airbnb power their AI-driven features? Or if you want to build your own machine learning models without investing in expensive hardware, this series is for you. In this video, we will explore the complete AWS AI ML ecosystem in depth. So let's dive in. AWS organizes its AI and machine learning services into three different layers. This structure helps you choose the right tools based on your needs and expertise. Layer 1, AI services are pre-built, ready to use APIs, no machine learning expertise needed. Just an API call, services like Amazon Rekognition for image analysis, Amazon Comprehend for text analysis, and Amazon Translate and Amazon Transcribe work out of the box for you. Layer 2 comes the machine learning platform that you are going to use for building custom models. Amazon SageMaker is the flagship service here, designed for data scientists and machine learning engineers. You get managed infrastructure for data prep, model training, hyperparameter tuning, and deployment. Now, layer 3 is the infrastructure layer, which provides compute, storage, and GPUs. Amazon EC2 instances with GPUs, Amazon S3 for data storage, and networking services gives you maximum flexibility. This layer is for teams that want full control over their machine learning stack. The key concept over here is choose your layer based on needs and machine learning expertise. If you need quick results, use AI services that is built in. But building custom models, you can use SageMaker. And if you want full control built on the infrastructure layer, you can also mix layers in the same application. Now let's start with layer 1, AWS AI services. These are the easiest and fastest way to add AI capabilities to your applications. No machine learning expertise required, just API calls. You don't need to know how machine learning works, train model, or understand neural network. Simply call a REST API from your code and get results instantly. Pre-trained models for common use cases. AWS has already trained these models on massive datasets you couldn't afford to compile yourself. They are production ready and constantly improved by AWS without you lifting a finger. Pay per API call with no infrastructure management. You only pay for what you use, no servers to provision, no GPUs to manage, no scaling concerns. AWS handles all the infrastructure, scaling, and reliability automatically for you. Now, categories include vision, language, speech, and business metrics. Vision services like Amazon Rekognition for image analysis, language services like Amazon Comprehend for text understanding, and speech services like Amazon Transcribe and Poly, and specialized services like Amazon Personalize for recommendation. Who uses it? Developers who need AI features quickly without training models. If you are building an app and need to add image recognition, sentiment analysis, or speech to text, these services integrate in hours instead of you building by yourself in months. Let's dive into Vision AI services. These services analyze images and videos to extract meaningful information automatically for you. Amazon Recognition. So Amazon Recognition provides image and video analysis using deep learning. It automates visual recognition without requiring any machine learning expertise. Just send an image or video via API and get results in JSON format. Face detection, object recognition, and celebrity identification are core features over here. Recognition detects faces and analyze attributes like age, gender, emotions, and facial landmarks such as eye position. It can identify thousands of objects like vehicle, furniture, and scenes like beach or city streets. So content moderation and PPE detection helps keep platform safe. Social media companies use recognition to automatically filter inappropriate content, including explicit material and violence from user uploads. It also detects personal protective equipment like hard hats and safety vest for workplace safety compliance. Next comes Amazon Textract. This extracts text from documents using intelligent OCR. Unlike basic OCR, Textract automatically understands document structure. It recognizes the forms, tables, and key value pairs without the template. OCR for scanned document, forms, and tables works automatically. Textract reads printed and handwritten text, extract data from invoices, receipts, tax forms, and medical records while preserving the logical structure and relationship. A real world use case would be upload an ID card, you get the complete picture. Rekognition extracts and verifies the face for identity verification, while Textract simultaneously extract all the text like name, address, ID number, expiration date. This combination powers KYC systems in banking applications and identify verification workflows. Now let's explore language and speech AI services. These services process text and audio to understand, translate, and generate human language for you. So Amazon Comprehend performs text analysis including sentiments, entities, and language detection. It automatically identifies whether customers' reviews are positive or negative, extract names and location from documents, detects the language being used, and find key phrases for you. Amazon Translate provides real-time language translation across 75 plus languages. It translates text while preserving context and meaning, making it perfect for localizing applications, translating user-generated content, or enabling cross-language communication. Amazon Polly converts text to speech with lifelike voices. It generates natural sounding speech in multiple languages and voices for you, supporting applications like audiobook narration, accessibility features for visual impaired users, and voice responses in customer service systems. Amazon Transcribe converts speech to text, turning audio into written text. It automatically transcribes customer service calls, meetings, podcasts, and videos with support for over 100 languages and features like automatic punctuation, speaker identification, and custom vocabulary. Let's talk about a real world use case. A customer support chatbot uses multiple of these services together. Amazon Transcribe converts the customer's voice into text. Then Amazon Comprehend analyzes the sentiment to detect the frustration. Amazon Translate handles non English queries, and Amazon Polly responds with a natural speech. This creates a fully automated multilingual support experience. Now moving to layer 2, Amazon SageMaker is the machine learning platform for data scientists who need to build custom models from scratch. Now designed for data scientists or and machine learning engineers for building custom models, SageMaker is specifically built for teams that need models tailored to unique business problems that pre-built AI services cannot solve. Features cover the entire machine learning lifecycle like data preparation, training, tuning, deployment, and monitoring. SageMaker Studio provides tools for data preparation with data wrangler, model training on scalable infrastructure, automated hyperparameter tuning, one-click deployment to production endpoints, and continuous monitoring with model monitor. Supports all popular machine learning framework including TensorFlow, PyTorch, and Scikit-learn. You can bring your own code and algorithms, use pre-built containers optimized for these frameworks, or leverage AWS built-in algorithms. Data scientists aren't locked into proprietary tools. Managed infrastructure means no server management. SageMaker handles provisioning compute instances, storage, networking, and scaling automatically for you. You select the instance type you need, CPUs or GPUs, and SageMaker manages everything else for you. The key benefit focus on model building, not infrastructure. Data scientists and machine learning engineers spend time on what matters, experimenting with features, tuning algorithms, and improving model accuracy. So instead of configuring servers, managing dependencies, or troubleshooting infrastructure issues. Let's break down the key component of Amazon SageMaker. Each component handles a specific part in the machine learning lifecycle. SageMaker Studio is a web-based IDE for machine learning development. It provides a unified interface where data scientists and machine learning engineers can write code in Jupyter Notebook, visualize data, track experiments, and manage the entire machine learning workflow without leaving that specific browser. SageMaker Training provides distributed training on managed infrastructure. It automatically splits large datasets across multiple GPUs for parallel training, achieving near linear scaling efficiency. You can use EC2 spot instances to reduce training cost by up to 90%. SageMaker endpoints deploy models as APIs for predictions. Once your model is trained, SageMaker creates secure HTTPS endpoints that your application can call for real-time predictions. It handles auto-scaling, health checks, and security patches automatically. SageMaker Autopilot is a auto machine learning that automatically builds the best model for you. You provide a dataset and target variable, and Autopilot explores different algorithms, tunes hyperparameters, and ranks models by accuracy. It's perfect when you need results quickly without manual experimentation. Then real world use case, build a custom fraud detection model for your business. So for that, you would load transaction data into SageMaker Studio, use Data Wrangler to prepare features for you, train multiple models with distributed training, and use Autopilot to find the best algorithm and deploy the winning model as an endpoint and monitor it continuously for performance degradation or data drift. Now let's explore Amazon Bedrock. So AWS generative AI platform that gives you access to most powerful foundation models available today. Access leading foundation models including Claude, Llama, and Stable Diffusion, along with its own proprietary models of Nova family. Bedrock provides model from these all vendors, and it has its own model like Titan models, and this all can be accessed through a single API. You can choose the best model based on your specific task without switching the platforms. No need to train your own LLMs. Training foundation models from scratch costs millions of dollars and require massive GPU clusters. Bedrock eliminates this barrier by providing pre-trained, production-ready models that you can use immediately through simple APIs. Customize models with your data using fine-tuning. Bedrock lets you privately adapt foundation models to your specific use cases using techniques like fine-tuning and RAG, that is retrieval augmented generation. Your training data never leaves your AWS accounts, ensuring complete security and privacy. So you can pick an existing model of ChatGPT, then train your data onto it so that it can give you specific results based on your data. Now, building Gen AI applications like chatbot, content generation, and code assistance create intelligent agents that execute complex multiple step tasks, automate customer service workflow, generate marketing content, or build AI powered coding assistants. Bedrock provides building guardrails to prevent harmful outputs and reduce hallucination for you. That is one of the key points that we would be looking forward for. And the key benefit, use powerful Gen AI models without massive infrastructure. Bedrock is serverless and fully managed. No GPUs to provision, no cluster to maintain, and automatically scale based on demand. You focus on building applications while AWS handles all the infrastructure complexity for you. Now we reach layer 3, infrastructure services. This layer gives you complete control over every aspect of your machine learning infrastructure, from storage to compute to deployment. So Amazon S3 stores training data and model artifact. S3 provides virtually unlimited storage for petabytes of training data, intermediate results, and trained model files. It integrates seamlessly with AWS machine learning services and offer 99.999% durability. Amazon EC2 and GPUs trains model on powerful GPU instances. You get access to NVIDIA GPUs as well as AWS custom Trainium 2 chips that deliver 4x performance improvements. EC2 P5 instances provide petabyte scale networking for distributed training across thousands of these GPUs. AWS Lambda runs inference without managing servers. For models that don't require GPUs, Lambda provides serverless compute that automatically scales from 0 to thousands of concurrent invocations for you. You only pay for actual inference time, making it cost effective for unpredictable workloads. Now, Amazon ECS and EKS deploy containerized machine learning models. Package your models in Docker containers and deploy them on managed Kubernetes or AWS native container orchestration, that is ECS. This gives you fine-grained control over scaling, networking, and resource allocation. Who uses this? Advanced users needing full control over infrastructure, research teams building custom distributed training systems, organizations with unique security requirements, or companies optimizing for specific cost and performance target which are going to use this layer. You manage everything but gain maximum flexibility. Now, do you choose which AI services to use? Let's break down the decision making process based on the specific needs and expertise. Use AI services if you have common use case in vision, text, or speech and need a quick solution. If you are building standard features like image recognition, sentiment analysis, or speech transition, pre-built AI services that AWS offers get you to production in hours instead of months. So no machine learning expertise are required over here. But it's important for you to understand, do you want to save time or do you want to build something custom? Based on that, you can take this decision. Next question would be, use SageMaker if what? If you need a custom model and have data science and machine learning expertise, so where pre-built services don't fit your unique business problems, like detecting defects specific to your manufacturing process or predicting churns based on your proprietary customer data, then SageMaker lets you build tailored models for you. At that time, you should choose it. So you should use Amazon Bedrock if you are building Gen AI applications and need LLM or foundation models, like for chatbot, content generation, code assistance, or any application requiring natural language understanding and generation. Bedrock provides access to latest foundation models without training them by yourself. And use infrastructure layer if you need maximum control or have specialized requirements. Research team experimenting with cutting edge architectures, organizations with strict compliance requirements, or team optimizing for extreme performance and cost efficiency manage and benefit from building on raw infrastructures. Practical example of image classification. So it demonstrates the choices that I have just discussed clearly. So for standard image classification, detecting objects, faces, or scenes, we can use Amazon Rekognition. But if we need to classify custom product categories specific to my business, like identifying different models of my industrial equipments, then I have to build a custom model with SageMaker using my labeled data. That would be the training data. So now let's see how a real e-commerce platform combines multiple AWS AI services to create a comprehensive solution. This example shows you how services work together in practice and in real life. S3 stores product images of your e-commerce website and customer data. The platform uploads millions of product photos, customer browsing history, purchase records, and user reviews to the S3 bucket. And this is going to be the centralized data lake which feeds all downstream AI services. Then comes Rekognition. So Rekognition provides automatic product image tagging. When sellers upload product photos, Rekognition automatically detects the object, colors, and attributes like a red sneaker, wooden furniture. This creates searchable metadata without manually tagging and improving the product discovery. Then SageMaker powers a custom recommendation engine. Pre-built recommendation systems can't capture the platform's unique user behavior patterns, so data scientist or machine learning engineer would use SageMaker to train personalized model on browsing history, purchases, and seasonal trend. The model deploys a real-time endpoint serving recommendations. Then Comprehend analyzes product reviews for sentiment. It actually extracts whether reviews are positive or negative, identifies the common complaints or praises themes, and surfaces trending feedback to the sellers. This helps prioritize product improvement and highlight top rated items. And Bedrock powers an AI chatbot for customer support. Using Claude or any other foundational model, the chatbot answers questions about orders, returns, product details, and sizing. It's customized with RAG using the company's product catalog and policy documents for accurate responses. So real application often uses multiple services together instead of choosing one service. So successful solutions combine the right tool for each task. This e-commerce platform leverages 5 different AWS services, each handling what it does best, creating a seamless, intelligent experience. And that's a complete overview of AWS AI ML ecosystem. Thank you for watching, and I will see you in the next video.